everyone see my screen?
Yes, sir.
Oh, great. Good. So I've decided to start with acid, bases, and salts. This is a very important topic, and most likely you guys will be writing paper two. So the persons who did not write paper two this year, they got off easily. But if you check any CSEC paper, you would always see acid, bases, and salts being present on the paper. So it's a very, very important topic. It's a huge topic also. So we'll take a while to finish it. So those are the objectives for today. You're at the end of this, you're supposed to be able to define an acid, explain the ionization of an acid when dissolved in water, define an acid in terms of protons, and explain the properties of aqueous acids. Now, some of these things you guys might be aware of because you're supposed to have exposure to it in Form 2 and Form 3. So let's get right into it. All right, so this slide is telling us what is an acid. So basically, an acid has several definitions. That's one thing we need to be aware of. Different scientists defined acid in different ways. So the first definition that we have there, and which is one of the most common definition and the easiest one to remember, is that an acid can be defined as a substance that reacts with a base to form a salt and water only. So I think that's one of the easiest definition to remember. However, we also have an acid is a substance that donate protons, and this is in the Bronsted-Rowley's definition. So who can recall what is a proton? Can anybody tell me what's a proton?
Sir, is a stable particle.
I'm sorry?
A stable
A
just a-
stable particle? Not really what I'm looking for. Can anybody else? Can somebody help Kezia? Shania, what is a proton?
A subatomic particle.
It's a subatomic particle, good. But I need a bit more than that. It donates a proton. What exactly is this proton? We know it's a subatomic particle, yes, but I'm asking about the charge of it.
Is the positive charge of the atom.
Very good. And it's found in the nucleus. So that's very important when it comes to dealing with acids. And when we go to the next slide, you will see that. So apart from it being a proton donor, it also accepts a pair of valence electrons to form a bond. And this has to deal with the Lewis definition. So basically you'll see it going interchangeably. But these are just the various definitions that I put here. But the one that I actually want you to remember is the one at the top. Is that it reacts to the base to form a salt and water only. So that's the important one. Acids in their anhydrous form. So the word anhydrous means that they're not dissolved in water. So make note of that term. So if we say it's an anhydrous acid, we mean that this acid is not dissolved in water. Good, so it's not an aqueous acid, it's anhydrous. Are composed of covalent molecules, and we know what covalent is, right? It's between two nonmetals, and they may be solid, liquid, or gas at room temperature. And room temperature is 25 degrees Celsius or 298 Kelvin. Those are things that you're supposed to remember from fourth form. So I have here some examples of acids. We have solid acids, liquid acids, and gaseous acids. Now, examples of these would be citric acid, tartic acid, and ascorbic acid, which is vitamin C. Now, these acids can exist in a solid form, crystalline solid form. And it's important to know that, example, the vitamin C tablet that you take, it's a solid form, right? So in terms of a liquid acid, you have seen it before, the sulfuric acid and nitric acid in the lab. And gaseous acid, it would be like hydrogen chloride gas, which is hydrochloric acid, but in a gaseous form. I have a note there. All acids have hydrogen in their formulas. Example, HCl. So this is very important when distinguishing between acids and bases. So we need to be able to look at the formula and to be able to say if it's an acid or a base or exactly what type of compound it is. So it's important to remember that all acids have hydrogen in their formulas. Good. Now I have some names of some common acids that we would find in the laboratory or even in your home. So basically I have them listed out here and I wanted you to write the formulas to me on your own because when we looked at polyatomic compounds in Form 4, remember I've given you the sulfate ion, the nitrate ion, the phosphate ion. Well, the two at the bottom are organic acids. And I don't expect you to remember those, well, or to know them, because when we move on to organic chemistry, you'll have a better understanding how to write them. But the reason I gave you this is because I want you to have exposure to it. So for hydrochloric acid, you have HCl. Isn't that so? Good. So if we can look
Yes,
here,
sir.
we can see that it has the H in its formula. Isn't that so? We said all acids have hydrogen in its formula. Now let's look at sulfuric acid. Now if you look at the name of the acid, you could be able to tell me what type of compound will be present in this acid. So look at number 2, sulfuric acid. Can you tell me what compound we expect to find here?
Sulfur and hydrogen.
Good, you expect to find sulfur, right? Which that's correct, but we expect to see the salt. It's actually the sulfate ion, SO2
SO4.
negative and 4 bonding with the hydrogen, right?
Yes, sir.
That's what's actually happening there. So when to write this formula, this is going to cross over here, following the rule, and we're going to end up with H2SO4, right? So the formula did not appear by magic. That's how it came about. So if you open back your books, somebody can tell me the formula for the nitrate ion. It's actually NO.
NO3, sir. NO3 negative.
And you have it bound into the hydrogen. The phosphate ion is PO3 negative and 4 going to bond to the hydrogen. So basically you can write back these formulas to me. You're going to do that in your own time, but I'm just showing you how they came about. Metanoic acid, it's H, that's the hydrogen, bonding to the functional group of the organic acid, COOH, and you have ethanoic acid, which is CH3 COOH. Now you see how these are a bit different from the ones above? The reason being is because metanoic acid and ethanoic acid are organic acids. And when we move on to organic chemistry, we'll look at this in depth. But the group that I'm circling off here is the functional group of carboxylic acid. These are the group that you're going to look at to identify if this compound is an acid or not. And of course, you have the hydrogen present here and the hydrogen present here. But let's not spend too much time on that to confuse you. But the idea of this is to get you to understand that, there are different types of acid and they can be named differently and so forth. Everybody clear here?
Yes, sir.
All right, let's look at the ionization of acids in water. Now, this is very important to know. You need to understand how acids dissolve in water and try to understand this concept because it's going to come back when we look at bases. So when an acid, sorry, when acids are added to water, the acid molecules are ionized. What do we mean by ionized? They form ions in the water. Now, if you can recall, when we looked at bonding, we looked at anions and cations, isn't that so? And we say that anions are the negatively charged particle, and the cation are what? The positively charged particles, right? Now, looking at hydrochloric acid, HCl, can you identify the anion and cation there for me?
Varens, we're looking at, no, sir. HCl doesn't give a charge.
Jared, you sure about that?
Well, hydrogen is positive. Well, without looking at it, the words itself, hydrogen is positive, and the chlorine is chlorine.
It's negative. Very good.
It's negative.
Very good. So this is the anion. Sorry, this is the cation, and this is the anion here. Very good. So acids always ionize to form hydrogen ion, which is this here. When they dissolve in water, they're going to split apart to form the hydrogen ion and negative anion. So it could be more than one anions in the water, but in this case here, we're looking at hydrochloric acid, we only have one anion. The hydrogen ions then become attached to the polar water molecule, forming hydronium ion. So this is very important to remember. And I'm going to show you how this hydronium ion is formed. Forming the hydronium ion, which is sometimes called the hydroxymonium ion. Hydroxymonium ion, however you want to enunciate that word. Are we clear there? Any questions there?
No, sir.
So how does positive charge from the water attract the proton? Is it because the electrons from the water attracting that one positive hydrogen?
No, it has to do with the polarity of water, and it has polarity means the charges. It has a positive and negative charge. If we say something is polar, we mean it has opposite charge going on. And
yes, sir.
When I go over to the next slide, I'm going to explain that in detail. That's a good question, though. Good. Why is water polar? That's the question Jared would ask just now. How does this hydrogen get attracted to the water molecule? Now, if you look at the structure of water, we know that water is abbreviated chemically as H2O. Isn't that so?
Yes, sir.
Now, if you look at the structure, we have one oxygen and two hydrogens. Right? So remember that hydrogen itself is positive. So if hydrogen is positive, it's going to have a partial positive charge here. This sign here is sigma, and it means partial. So the two hydrogens have two partial positive charge, and the oxygen has a partial negative charge. Remember, oxygen is in group 6. It's going to have a negative charge. You see how all of these things are coming back together now to make sense? So,
yes, sir.
The oxygen is more electronegative. Electronegativity, remember, electronegativity is the ability to attract an electron to itself, the ability of a substance to attract an electron. Well, in this case here, since the oxygen is electronegative, it's going to pull away that positive charge from the acid to form the hydronium ion. Think you understand? So when it dissociates in water, it's going to split up into hydrogen and the anion. Now remember, this is a negative charge. And when this negative charge comes in contact with that positive charge, it's like a magnet, opposite sides going to attract. And when it attracts, it's going to form the hydronium ion.
Yes, the hydronium.
If H2O attracts another hydrogen, clearly it's going to form H3O positive. Remember, it's an ion, right? It has to be positive. So that's how we get the hydronium ion. So it's very important to remember that. Are we clear there?
Yes, sir.
Sir.
Water is a polar molecule because the electrons of the hydrogen atom get pulled towards the electrons of the oxygen atom. This makes a region of positive charge on the hydrogen atom and the negative charge on the other end of the molecule, which is the oxygen atom, which I just explained just now, right? That is why we have the partial positive and negative charge due to the difference in electronegativity of the elements, right?
Yes, sir.
In other words, the hydrogen ions that dissociate means that they're going to break apart in water, right? From the acid is bonded to the polar water molecule to form the hydronium ion. And I just showed you how we got that. Good. So let's look at the example of ionization. Example of ionization. So remember we say that ionization is when this acid breaks apart in water to form ions. Isn't that so? So if we look at hydrochloric acid here, for example, we can see that when hydrochloric acid, and I spelled out the word water there. Let's think about it being dissolved in water. It's going to break apart to give you H positive ions. It's not so hydrogen ions and the negative anion. That's not what we just read. Now, when it doesn't complete there, it has to form the hydronium ion. This is what acids do. They dissociate in water to form the hydronium ion. So this H positive ion that dissociates here is going to further react with the water to form the hydronium ion. Clear there?
Yep.
Good. Now, the overall reaction can be summarized as hydrogen chloride gas, because it's not in the aqueous form, so it's not going to be hydrochloric acid, it's going to be hydrogen chloride gas, reacts with water to give you the hydronium ion plus the negative anion, which is the chlorine. However, for simplicity, it could be represented as H positive and Cl negative, right? Because sometimes you would see it like this. But you know, really and truly, that this hydrogen is going to further react with the water here to give you this, to produce back this. Isn't that so?
Yes, sir.
Good. Great. So I have a little activity here for you to do. So I gave you the name of the acid. I gave you the name of the acid, and you can dissociate it in water to form the hydronium ion and the negative anion. So clearly it's very simple to do because we know we're always going to end up with a hydronium ion, but what is going to be the negative anion? That's what you need to tell me. And by looking at the formula right away, you can tell me what it is. Isn't that so?
Yes, sir.
Great. So I sent you this PowerPoint already. You can go through back it. Also, I'm going to put it in the Google Classroom. In addition, we need to look at general properties of aqueous acids. Remember, these are the acids that are dissolved in water. That's what aqueous means. So, basically, the presence of H plus ions in aqueous solution gives acids their characteristic properties. An aqueous solution of acids are described as being acidic, and they have the common properties. So basically what it's trying to tell you is because of this H positive ion that dissociates in the water, this is why acids have these properties. They all have a sour taste. They change blue litmus red. We looked at pH in the lab. We know this. We saw this with our eyes. The blue litmus changed to red. It has a pH less than 7. You guys did this in Form 2. And that's something you're supposed to remember. All acids have a pH from 0 to 6.9. They're corrosive. We know that for sure. That's why when dealing with acids in the lab, we got to make sure we have on our protective gears and so forth. And another important point is that they're electrolytes. So when acids are in the aqueous form, they're able to conduct an electric current. So those are the properties of acids. It's important you remember them. And for your homework, in not more than one paragraph, I want you to explain why hydrogen is considered a proton. All right? So basically, that's it for today's lesson. And that's how I'm going to do them. I'm going to break it up, put them in PowerPoint, and teach you. Would you guys prefer that?
Yes, sir. Sounds good.
And
Yes, sir.
then I send you the PowerPoint, you go through it back, and I'm going to send you the recording because I'm recording the session. And when I send you the recording, you can listen back to them, and then I'm going to do quizzes in Google Classroom. We're going to follow through. But I know people have genuine internet problem. That I understand. So that is for today's session. Are there any questions?
No, sir.
So I'll see you guys next week, Thursday. We will continue from this. We're going to continue. We're going to look at the reactions of acids. What I'm going to try to do is send the PowerPoint before we actually go into the class. So you guys can have a head start in reading. So have a great afternoon and thanks for coming to class.
Bye, sir.
Bye.
You too, sir.
Bye, sir.
Bye.